Download this code from codegive.com, link in the description below. Building a retrieval-ai agent in Python involves creating a system that can retrieve relevant information from a dataset based on user queries. This tutorial will guide you through the process using popular libraries such as numpy, pandas, scikit-learn, and nltk, natural language toolkit, or transformers from Hugging Face. Step-by-step tutorial. Step 1. Set up your environment. Make sure you have Python installed on your machine. You can create a virtual environment and install the necessary libraries using pip. Bash. Create a virtual environment, optional. Python venv retrieval-ai. Activate the virtual environment. On Windows, retrieval-ai /scripts/activate. On macOS /Linux, source retrieval-ai/bin/activate. Install necessary libraries. Pip install numpy pandas scikit-learn nltk transformers. Step 2. Prepare your dataset. For this tutorial, we'll use a simple dataset consisting of documents or text snippets. You can create a CSV file called documents.csv with the following content. CSV. ID text. 1. The sky is blue and beautiful. 2. Love this blue sky. 3. The quick brown fox jumps over the lazy dog. 4. A journey of 1,000 miles begins with a single step. 5. Sky is the limit when it comes to ambition. Step 3. Load the dataset. We will load the dataset using pandas. Python. Import pandas as PD. Load the dataset. df equals pd read_csv, documents.csv. Print, df. Step 4. Text pre-processing. You should pre-process the text data to make it easier to work with. This might involve tokenization, lowercasing, and removing stop words. Using nltk, you can do the following. Python. Import nltk. From nltk.corpus import stop words. From nltk.tokenize import word_tokenize. Import string. Download stop words and punct. nltk.download, punct. nltk.download, stop words. Pre-process the text. Stop_words equals set, stopwords.words, English. Def pre-process, text. Tokenize and lowercase. Tokens equals word_tokenize, text.lower. Remove punctuation and stop words. Tokens equals word for word in tokens if word not in stop_words and word not in string. Punctuation. Return.join, tokens. df processed_text equals df text.apply, pre-process. Print, df id, processed_text. Step 5, create a vectorization method. For retrieval, we can represent the documents as vectors using techniques like tf-idf or word embeddings. Here, we'll use tf-idf from scikit-learn. Python. From scikit-learn.feature_extraction.text import tfit vectorizer. Vectorize the processed text. Vectorizer equals tfit vectorizer. tfit_matrix equals vectorizer.fit_transform, df processed_text. Step 6, implement the retrieval function. Now, we can create a function to retrieve the most relevant documents based on a user's query. Python. Import numpy as np. Def retrieve, query, top_n equals 3. Pre-process the query. Processed_query equals pre-process, query. Query underscore vector equals vectorizer dot transform, processed underscore query. Calculate cosine similarity. Cosine underscore similarities equals np dot dot, tfidf underscore matrix, query underscore vector dot t, dot to array, dot flatten. Get the top underscore n indices of the highest similarities. Top underscore indices equals cosine underscore similarities dot argsort, top underscore n colon dash 1. Return the top underscore n documents. Return df.eloc top underscore indices. Example usage. Query equals what is the color of the sky. Results equals retrieve, query. Print, results ID, text. Step 7, testing the retrieval agent. You can now test the retrieval-ai agent with different queries. Try changing the query variable to see how well it retrieves relevant documents. Conclusion. In this tutorial, we've built a simple retrieval-ai agent using Python. We've covered loading a dataset, pre-processing text, vectorizing it with tf-idf, and retrieving the most relevant documents based on user queries. Additional improvements. 1. Use word embeddings. Instead of tf-idf, consider using pre-trained embeddings like word2vec, glove, or bird for better semantic understanding. 2. Fine-tuning. If you have a specific task, fine-tune your models with domain-specific data. 3. User interface. Build a simple web interface using Flask or Django to interact with your retrieval-ai agent. 4. Scalability. For larger data sets, consider using Elasticsearch or a similar technology to handle querying efficiently. 5. Evaluation. Implement evaluation metrics to measure the performance of your retrieval system. Feel free to expand on this basic framework to create a more sophisticated retrieval-ai agent. Building a retrieval-ai agent in Python involves several components: data storage, querying, and response generation. A retrieval-ai can take user input, query a dataset, and return relevant information. Below is a step-by-step tutorial on how to create a simple retrieval-ai agent using Python. Overview of steps. 1. Set up the environment. 2. Prepare the dataset. 3. Build the retrieval logic. 4. Create a simple user interface. 5. Test the agent. Step 1. Set up the environment. Make sure you have Python installed on your machine. You may also want to set up a virtual environment and install necessary libraries. Bash. Create a virtual environment, optional but recommended. Python venv retrieval_ai_env. Source retrieval_ai_env/ben/activate on Windows. Use retrieval_ai_env \scripts\activate. Install necessary libraries. Pip install pandas numpy scikit-learn. Step 2. Prepare the dataset. For this example, we will use a simple dataset stored in a CSV file. Create a data.csv file with the following content. CSV. ID title content. 1. Python programming. Python is a programming language that lets you work quickly and integrate systems more effectively. 2. Data science. Data science is a multidisciplinary field that uses scientific methods, processes, algorithms and systems to extract knowledge from data. 3. Machine learning. Machine learning is a subset of artificial intelligence that focuses on building systems that learn from data. 4. Web development. Web development is the work involved in developing a website for the internet. Step 3. Build the retrieval logic. We will use tf-idf, term frequency inverse document frequency, for vectorizing the text data and cosine similarity for finding relevant documents. Python. Import pandas spd. From scikit-learn.feature_extraction.text import tfit vectorizer. From scikit-learn.metrics.pairwise import cosine_similarity. Load dataset. Data equals pd read_csv, data.csv. Initialize tfidf vectorizer. Vectorizer equals tfit vectorizer. tfit_matrix equals vectorizer.fit_transform, data content. Def retrieve_answer, query. Transform the query to the same tfidf space. Query_vec equals vectorizer.transform, query. Calculate cosine similarity between the query and the dataset. Cosine_sim equals cosine_similarity, query_vec, tfit_matrix. Get the index of the most similar document. idx equals cosine_sim0.argmax. Return the title and content of the most similar document. Return data.eloc idx title, data.eloc idx content. Step 4. Create a simple user interface. Now, we will create a simple console interface to interact with the AI agent. Python. Def main. Print, welcome to the retrieval-ai agent. Print, you can ask about Python, data science, machine learning, or web development. Print, type exit to quit the program. While true. Query equals input, \n enter your question. If query.lower, equals exit. Break. Title, content equals retrieve_answer, query. Print, f\n title, title\n content, content. If __name __main__. Main. Step 5, test the agent. Run the Python script and ask questions related to the topics in your dataset. Bash. Python retrieval_ai.py. You can now enter questions like what is Python, tell me about data science, etc. The agent will return the most relevant document based on the content in your CSV file. Conclusion. You have now built a simple retrieval-ai agent using Python. This agent can be improved by using a larger and more comprehensive dataset, implementing more advanced NLP techniques, such as word embeddings or leveraging pre-trained models like BERT, adding additional features like context retention, conversation flow, or integrating with a web service for a more user-friendly experience. Feel free to expand upon this basic framework to suit your needs.